Hey, this will be a quick video. We're going to be using all properties of these logs at once. So we want to write this as a single logarithmic expression. So as a single logarithm. So we're only allowed to write the word log once, even though it might appear more than once in here. So for this first one, I'm only allowed to write log once. Now they both have a base of 3. And since it's separated logs, it's separated addition, I know I'm going to be multiplying at some point. Well, let's look at what I'm multiplying. Well, I have a problem here with this 1/4. Because I want to write this as a single log, I'd like to write this attached to the 2. So I'm going to use the power property, but in reverse. Instead of having like the power and then bringing it to turning it to kind of a coefficient in front of the log, I'm going to do the reverse, and I'm going to move it back on top of what its base is. So this is going to end up being 2 to the 1/4 power right there. And this separated addition is going to end up being, that's going to have like the x. That's where we're going to get the x right here. But similarly, the same thing happens with that 1/4 there. The 1/4 is going to be a power of that x there. So I'm going to write, again, that power of 1/4 right here. Now, this leads me to something. This is a perfectly fine answer. There's nothing wrong with this. This is accurate. I did meet the conditions that they said, hey, write it as a single logarithm. If you want, there is another alternate version of this. Since they're both being raised to the 1/4 power, I could write like the product and then that together to the 1/4 power. So that also would be an acceptable answer. Oops, I wrote 1/2 by accident. 1/4 power. If you wanted to write it even maybe slightly differently, you could write log base 3 of 2x. And well, what is a 1/4 power? That's a 4th root. So technically, you could write it this way too. Either way, I'm writing that as a single logarithm, a single logarithmic expression with while writing log only once. And in fact, another way, another way you could write this that would still be correct. Since the 1/4 is in front of both of those, you could do 1/4 of log base 3 of 2x. So really, that's 4 ways to write this single logarithmic expression. This way is actually like that one's quite nice, but the one that you would expect to see on a test would be probably the one that looks like this second option here. This looks sloppy, even though it's correct. Putting them like the 1/4 combined just looks a little better. But all of these are possible correct choices. Now, for this last one, we're still using the multiplication property, which is right here. The product property is what they call it. So these are going to be like the 4 and the y seem like they're going to be multiplied together at some point. But then this subtraction, what does that imply? Well, that implies division. That's the quotient property right there. So we could still be using that power property. So you could bring this 1/2 kind of in front of this right here. But before we do, let's simplify this, and I'm going to color code this. Let's simplify this first. All of these are log base x. So I'm going to write log base x of 4y. And since that 1/2 is in front of both of these, you could write the 1/2 right there. Alternately, if you want to use the power property to put the 1/2 up here, there's nothing wrong with doing that. You could put the 4y and you can write the 1/2 power, but if you choose to do that, here's where you got to be careful. All of the 4y gets the 1/2 power if you're going to write it that way. And what happens here is, well, if we're going to go ahead and do that, we can also, a 1/2 power is a square root. But if we're going to square root that number, we got log base x still, but the square root of 4 can be simplified to 2. So that's 2, and then they have the square root of y. Or you could write log base x 2, you could write y to the 1/2 power. So if you're going to go through the trouble of like putting the 1/2 power there, it makes sense to simplify the radical. Now we're going to introduce this second part. Now remember, the base of all of these logs is x. That's what allows us to use this property. This separated subtraction can be written as a division, so we can write it as like 1 log, like the 3 log z right here. So for this 3, if I want to write it all as one common log, I can put the 3 on top of the z right there. So that's a z to the third. But the z to the third goes on the bottom. So I can write that like this. But this would be the preferred final answer for this long drawn out logarithmic expression. And you see how it requires three different logarithmic expressions? You can write it as a single logarithm this way. Even though writing it this way, so like that I'm carrying this 3 log z all the way down, even though you could write the square root of 4y in the answer, it's just square root of 4 just screams out, simplify me. If it was square root of 4 or square root of 16 or square root of 9, like you just really want to simplify that radical where you can instead of just leaving it alone. So the best answer for, simplifying number 57 using all three of those properties in the end would be log base x. Let me write that a little bit cleaner. My x is a little bit too high. So log base x of 2 times y to the 1/2 all over z cubed. If you want, when you're printing this, it looks a little better if I was printing it, say, with like Microsoft Word. You don't need the parentheses, but when I'm writing it, I'm a little extra careful. I put the parentheses just because my handwriting and like my line, drawing, it's not as clear to like see where the subscripts are. And it's not as clear, to see that this is like all of this is inside of the logarithmic argument. So that's the correct answer, but using parentheses, which what I prefer. But if you can do these two problems, applying these three properties right here, turning again either 2 or 3 separated logarithmic expressions into a single logarithm, then you're going to be in good shape for the kind of questions you're going to see on the assessments.